This is lesson 21, applications of proportions. We talked about proportions last week. On Friday, we went through rates, ratios, and proportions kind of quickly, but proportions are when we talk about one value compared to another value. It's like a fraction, and we could make proportions. We need proportions when we, compare smaller things to larger things. For example, like when you bake a cake, and the recipe says to make one mini cake, you need 2 cups of sugar. What happens if you want to make like enough for 10 of your friends? Well, then you would have to make a proportion to know how much of each ingredient to put in. Okay, here are the steps. Write those down, please. All right, and then proportions, just to solve. Once we set it up, the proportion part is just like last week, the same steps as last week. Okay, so here we go. Number 1, to make a perfect pot of 12 cups of coffee, you need to have 6 tablespoons of coffee. How many tablespoons do you need for 100 cups? Okay, so raise your hand if you ever help like your mom or dad or someone throw a party where they're like, we need to make a lot of coffee because we have a lot of people, and then you get one of those big like containers of coffee. No one has ever done that? Okay. Well, you probably will one day, okay? So, I know as adults we do that. We make a throw party or we have, like at work, we might have a big thing of coffee. So, to make a perfect pot, so we need 12 cups of coffee, you need to have 6 tablespoons of coffee. So, you need to set up a proportion first by putting 2 fractions equal to each other, okay? So you just draw the fraction lines first. And you need to figure out what's going to go in the numerator. It has to be the same thing in both numerators. So I'm going to put cups on each of these. So I'm going to put cups in the numerators, and in the denominator, the other thing we're comparing is 2 tablespoons. So I'm going to put big TB, right, which stands for tablespoon. Okay? So on the first proportion, we know that to make 12 cups of coffee, I need 6 tablespoons, right, of coffee, right? So the question is, if I wanted to make 100 cups of coffee, how many tablespoons, right? That's where the question mark is. So we just set up our proportion. So in the place of tablespoons, I'm going to put x there, and then I just cross multiply like last week. 12 times x is 12x. And then 6 times 100 is 600. Okay, I'm going to divide both sides by 12. And 600 divided by 12. Could do that on my head, but do a side problem if we need to. That's totally fine. 5 times 12 is 60. Subtract to get 0, 0. 12 goes into 0, 0 times. So the answer is x is equal to 50, or we need 50 tablespoons to get 100 cups of coffee. Does that make sense so far? Okay. So what did I just do? I started off by... First thing I did is I started off by making 2 proportions equal to each other. I knew cups was going to be in the numerator, tablespoons in the denominator. It could be either or. Made my first proportion, 12 cups is equal to 6 tablespoons. So how many for 100 cups? Multiplied, divided both sides by 12, and we get did a little side problem here. We get x is equal to 50 tablespoons. Okay, does that make sense? So if you were making a ton of coffee for a party, you'd have to do 50 tablespoons. And we talked about how the conversion factors, so you wouldn't just use a tablespoon, you use cups, of course. Okay, number 2, a car gets 35 miles per gallon. How many gallons would you need to buy to travel 300 miles? Okay, so how many gallons? So first thing I'm going to do, just like before, set up a proportion problem. So we're going to do 2 fractions equal to each other. Okay. First thing we talked about was miles, so we'll keep miles in our numerator. You guys want to keep the same thing in the numerator. Denominator, we said gallons. That's the other thing. So, okay, so we know that the car gets 35 miles per gallon, so I'm going to put 35 miles per 1 gallon. The question is, how many gallons do I need for 300 miles, right? We don't know how many gallons. That's the question here. That's the question. It says how many gallons. That's the key, is the word gallons. How many gallons, right? We don't know. So that's going to be our variable x. So we cross multiply 35 times x is 35x. 1 times 300 is 300. We make these equal to each other. Divide both sides by 35. So x is equal to, well, we don't know that perfectly. We have to do with side problem. 35 goes into 30 0 times. 35 goes into 300. Let's see, 270, 8. 8 times 5 is 40. 8 times 3 is 24. Plus 4 is 28. You get 20, right, is a remainder. But I want to know exactly how many gallons I need to get, so I'm going to add a decimal point and a few zeros at the end. Bring down the next zero. 35 goes into 200. Let's see, 2, 4, 5 times. 5 times 5 is 25. 5 times 3 is 15, plus 2 is 17. Remainder is going to be 25. Bring down the next one. Goes in 6 times. 6 times 5 is 30. 5 times 3 is 15, plus 3 is 18. Oh, wait, no. 6 times 3 is 18, plus 3 is 21. And we're back to 30 again. So we know it's going to be a repeating decimal. Okay, so it's going to be 8. X is equal to 8.56 gallons. Okay, that's it. Any questions on this? Yes? No? Okay, so the hard part today is setting up the proportion, and then it's just a repetition of the skill you learned Friday. Okay? So what I'd like you to do is... Okay, number 3. Here we go. Let's get this done. Let's do a couple more. I think we'll be okay.
This is a cool background.
Okay, here we go. Number 3. A dog eats 12 cups of dog food every 3 days. How many cups of dog food do you need for 1 week? Okay. Okay, so let's work this one out together. We want to set up a proportion for step 1. Set up the proportion. So let's put 2 fraction bars with an equal sign in the middle. Okay. What label should we put in the numerator? Cups or days? What do you think? It doesn't really matter. It just has to be organized. We could put days in the numerator. Which one do you want? You want to try with you want to do cups in the numerator? Okay. Okay, good. Yeah, good. I like the way you're thinking. Cups first because it says it first. That's great. And then the denominator is going to be D, right? For days. Okay. What information does it give us? A dog eats how many cups? 12 cups in how many days? 3 days. Good. Okay. What's the question asking you? How many what? No. How many?
cups?
So we don't know how many cups. That's the question mark we're putting there. And then in how many days? It's asking in weeks, though. It says how much in a week. How many days in a week? 7. So you kind of have to think a little bit. You have to think, okay, 7 days. All right? So instead of the question mark, let's put an X there also, because we don't know. Okay? We're not doing that anymore. Okay? So, 12 times 7 is? 84. Good. 3 times X is? Good. How do I solve for X? Divide by 3, right? Okay? What's 84 divided by 3? What? Exactly? Yeah? Yep. 28. Let me just double check your work. Yep, 28. It's 8, yep. On the dot. Cool. So X is equal to 28 what? 28 what? Cups, okay? That's in 1 week. 28 cups. Does that make sense? Yes or no? Good? Alright, let's do one more. Number 4. Oh, sorry, number 4. Okay, number 4. A typical student sleeps 50 hours in 1 week. How many hours does a student sleep in 15 days? Okay. So, first step, everyone. How many, or what do we need to do first?
Put it in a proportion.
Okay, put it in a proportion, so we're going to put two fraction signs. Okay, what's going to be in our numerator? What do you think you want in our numerator this time? Yeah.
50H.
50. Well, let's talk about the labels. Don't worry about the numbers yet. What are the labels in my numerator?
Hours.
Hours. Okay, good. Excellent. So we're going to put HR for hours. That's what the label is for hours. Okay, and what do we want to put in our denominator? Weeks? Weeks?
Days.
Days or weeks? Why days?
Weeks.
Because it goes to 15.
Maybe days.
Oh, it ends at 15 days. How many weeks is 15 days?
2 weeks and 1 day.
Oh, it's 2 weeks and 1 day, right? Is it perfectly 2 weeks?
No.
No, so you kind of have to think a little more finely, a little more detailed, right? So we want to really think in days, right? Because we know that there's 7 days in a week. It's going to be more accurate to do this way. If you put weeks, you're going to get you're not going to get an accurate answer. Okay. Okay. What information does it give us for our first proportion? The student typically sleeps what? 50 hours in how many days? Good. Okay. So what's the question asking? How many what? Hours. So what should I put in for hours in front of hours? X. Okay, good. How many days? 15. Okay, go. Okay. 107.14. Okay, so it's 50 times 15 is 750, which is equal to 7 times x, which is 7x. Divide both sides by 7. You got to do some long division, right? So you got to go 750. And I know that it's not going to go in perfectly, so I'm going to add a couple zeros there. Okay. Divided by 7. Okay, 7 goes into 7 once. 1 times 7 is 7. This is where I saw some people make a mistake. Don't forget to bring down the 5. How many times does 7 go into 5? 0. Some of you made a mistake. You just jumped to the 4. Okay, so 0 times 7 is 0. Subtract, you get 5. Bring down the next number, you get 7 goes into 50. Good. 7 times 7 is 49. Subtract, you get 1. Bring down the next number, 0. Bring your decimal point is 1. 1 times 7 is 7. Subtract, you get 3. Bring down the 0, and you get 4. It goes into 28. And you could keep going here. I don't think it's a perfect or rational number, so goes in twice, right? So your answer is going to be 107.14 hours. Okay? Or x is equal to that for number 4. Okay, so the other problems that I have for the lesson are very similar. I think we're getting it, so I'm going to end the lesson there.